Hello, a very good evening to all, and welcome to the class. This is class number 6 for this chapter, that is solution. So far we are cover all the important topics and all the important laws in this chapter, that is solution. Now today we are going to discuss Van't-Hoff factor, because this one is very important in colligative properties, and how colligative properties change after the introduction of Van't-Hoff factor into the questions, right? So try to understand the Van't-Hoff factor in detail, because in last class we already studied about the what happened in case of association and dissociation. So in this class we are going to study the Van't-Hoff factor, and it's very easy to understand. If we learn about the association and dissociation, then you can easily understand this thing, right? Now after this, what we plan for today, now we are going to solve some numericals related to this Van't-Hoff factor, colligative property, so that you have some idea what kind of questions basically ask from this chapter, right? So this is what we are going to do today in our class, right? So let's join the class, everyone. I hope my voice and my screen is visible to you all, right? Okay, so let's start with the today's session, right? Okay, so what is Van't-Hoff factor? If someone asks, what do you mean by this term Van't-Hoff factor, and why they are important in colligative properties, how colligative properties change after the introduction of Van't-Hoff factor? So basically, the normal value of colligative properties is directly proportional to the number of particle of solute taken, right? Because in the beginning itself, we know that the colligative properties is what? Any property which depend only on the number of solute is known as colligative properties. So the normal value of colligative property is directly proportional to the number of particle of the solute taken. And now abnormal value, because we already studied in a last class what is abnormal quantities, what is abnormal molecular mass, what is abnormal molecular mass, and abnormal colligative properties. We have already studied this thing in our last classes, right? So, abnormal value of colligative properties is also directly proportional to the number of particle of the solute after dissociation or association, right? If I'm talking about NaCl, so let's see with some example NaCl. So, if I'm talking about the colligative properties of NaCl, then it depends. Yes, 1 mole of NaCl is present, then elevation in boiling point or depression in freezing point or any colligative properties is here only for the 1 mole. That is 1 mole containing the Avogadro number, that is 6.023, 10 k power 23 atoms. So this is valid for this only. But now in case of NaCl, we know that NaCl in aqueous solution, they dissociate to give one Na positive ion and one Cl negative ion, right? It dissociate to give Na positive ion and Cl negative ion. So it will produce two ion, right? It will produce two ion. So their number of particle being changed. Now their colligative properties also change. So here I am written as number of particle of solute taken, but abnormal value of colligative properties is directly proportional to the number of particle of the solute after dissociation or association. It means by NaCl or any compound like A2SO4, Al2SO4. So by these ionic compounds, actually they dissociate to give more number of ions. So their colligative properties also change accordingly, right? So this give rise to the abnormal value of the colligative properties. Similar, if I'm talking about the weak acid like CH3COOH, like ethanoic acid, or we say carboxylic acid in case. So they form associate to give a larger molecule. So in this also the colligative properties get changed. So abnormal value of colligative properties is directly proportional to the number of solute after dissociation or association. So this point is very important here, right? Now, the ratio of the two values, that is abnormal colligative properties upon normal colligative properties, is termed as Vent-Off factor. So if someone asks, what is Vent-Off factor? So what is Vent-Off factor, beta? Vent-Off factor means it is the ratio of the abnormal colligative properties to the normal colligative properties. And what is this abnormal colligative properties? Abnormal colligative property is nothing but equal to number of particle after association or dissociation to the total number of particle before association or dissociation, right? So this is all about the abnormal colligative property to the normal colligative property, because we know that abnormal colligative property is number of particle after dissociation or association. Or what is the normal colligative properties, beta? Here number of particle before association or dissociation. Thus we can define I as actual number of particle in the solution divided by number of particle taken. So we can define I in a many ways, and each one having the same meaning, right? So this is all we can define Vent-Off factor. I hope this is clear to you all. This is clear to you. Anyone having any kind of doubt till this? No? Right. So this is all about the Vent-Off factor. कि हम कैसे Vent-Off factor को find करेंगे? How will you find Vent-Off factor? And Vent-Off factor is defined as the ratio of these particular things. Okay. Now, so as we know that as the colligative properties is inversely proportional to the molecular weight, because we already know that na colligative properties like elevation in boiling point or anything, we know that elevation in boiling point is directly proportional to the molality, and molality is nothing but mass upon molecular mass into 1000. So it is inversely proportional to the molecular weight. So we can also write now I as a inversely. So normal molecular weight upon abnormal molecular weight. So we can write I as well. Okay. Now this one is very, very important. These 2 points is very important. We already studied this thing, how 1 plus n minus 1 into alpha. This comes in case of dissociation, and 1 plus 1 upon n minus 1 alpha. This is come in case of association. So always remember that, beta, whenever alpha is greater than 1, always remember this thing. Whenever alpha is greater than 1, it means always say no alpha, I. Okay, whenever the Vent-Off factor I is greater than 1, remember this thing, and always undergo dissociation, right? So in some question, maybe they ask whether this solid undergo association or dissociation. You just have to calculate I. If I is greater than 1, then it must undergo dissociation. If I is less than 1, I is less than 1, then it must undergo association, right? So this is for association, and I is greater than 1 for dissociation. So just try to remember this thing better. What is in case of dissociation and in association. I hope this is clear to you all. What is abnormal molecular weight and how I is related to molecular mass, right? Okay, very good. Now, in case of Vant-Off factor is known, the various colligative properties would be given by. अगर वेरियस अलग अलग colligative properties को देखो तो कैसे लिख सकते हो? For example, बेटा, अगर मेरे को लिखना हो elevation in boiling point, तो this delta TB can be written as KB into molality into this factor I. So just multiply each one by I. Now on the similar basis, if I have to write the depression in freezing point, so it is equal to KB into M into I. Here KF is present, right? Molar depression constant, KF. Now on the similar basis, osmotic pressure. How will you write osmotic pressure, beta? Osmotic. So osmotic pressure as osmotic pressure. So atmospheric pressure is nothing but pi, and we know that what the expression for pi comes out to be, beta? It comes out to be CRT. So we can write as CRT into I. This is for the osmotic pressure. Similar in the case of relative lowering in vapor pressure. Relative lowering in vapor pressure. So this can also be write as P naught minus PS upon P naught is equal to mole fraction of solute, right? Mole fraction of solute multiply by the Van't Hoff factor. So we can write each colligative properties like this if the Van't Hoff factor comes into the picture. And how would you know the Van't Hoff factors comes into the picture, beta? Whenever some ionic compound is given, whenever it's given there some electrolyte is given, whenever it undergoes some dissociation or association, degree of dissociation is given, then we get to know, yes, in this we have to use this Van't Hoff factor I. And this all four colligative properties, we already studied these all four colligative properties, right? And this four colligative properties changes to this when the Van't Hoff factors comes into the picture. Nothing, just multiply by I. So you have to know how to calculate I, how to put the value of I when the alpha is given, when alpha is not given, then how will you identify what is I, whether it is equivalent to N or not. So these type of things we are going to solve through a question, right? So let's do some question, and by doing some question we actually understand this concept and understand this portion in a very good way. Okay, so let's do some questions so that our concept becomes crystal clear. Now, so this is the first question, and I hope all of you can easily solve this question, because this question is very, very easy. And we already discussed this type of questions when we are talking about the colligative properties and the Van't Hoff factors, right? So let's see what the question asks, beta, and try to solve this question as well, you all. Which one of the following aqueous solution will exhibit highest boiling point? So you have to identify in this which of the following aqueous solution will exhibit highest boiling point. So we know that. How will you know which one show highest boiling point or not, beta? How will you calculate this thing? Which one show highest boiling point or not? Yes, we know that delta TB is nothing but is equal to Kb, right, into molality into I, right? So delta TB is nothing but Kb into M into I. This is all about the delta TB. Now you have to identify in this question which of the following will show highest boiling point. Now let's see. So if I'm talking about the first one, right? If I'm talking about the first one, how will you identify, beta? How will you identify? If I'm talking about the Na2SO4, right? Na2SO4 and KNO3. How will you identify? Can anyone tell me what is the number of mole for this? Yes? Anyone? Number of mole for this one? This is question number 23, right? So this is question number 23, and you have to identify, beta, which will show the highest boiling point. So how will you identify? We know that in case of Na2SO4, Na2SO4 dissociate to give 2Na plus 1SO4, right? In case of KNO3, so KNO3 dissociate to give K plus 1NO3, right? So here I is nothing but I is equal to 2. And here, if I assume 100% ionization takes place, and here I is equal to 3, right? So here the number of particle is more as compared to KNO3, and both having the same concentration, that is 0.1 molar and 0.1 molar. Now, if I'm talking about this one, that is a 0.1 molar of urea and 0.015 molar of glucose. So both having a covalent compound, right? So both having a covalent compound having concentration more than this 0.015 and this is 0.010, but having only one molecule of urea or glucose, right? So on this question you have to know what is Na2SO4 and how will you calculate this thing, right? So you can calculate this thing by easily just knowing the number of ions, right? So if you know the number of ion that will undergo association or dissociation, then you can easily identify. Now tell me the correct answer for this question, beta. We all know that delta TB is nothing but Kb into M into I, right? So for this, we know that delta T, the first one, delta T is directly proportional to 0.01. This is the concentration, right? And the number of particle for this 3. The Vector factor comes out to be 3. Now, for the second one, that is delta T is directly proportional to 0.01 into 2, right? Into 2. Now, for the next one, that is delta T is directly proportional to 0.015 into 1, because urea and glucose are the covalent compound, they do not dissociate or associate, right? Similar, delta T is directly proportional to 0.015 into again 1. So you have to find out of these four which one give maximum boiling point. So it is very simple, beta. That is this one having more number of, because 3 into 0.1, right? They here only 0.15 into 1. So this will give us the maximum boiling point. So if you know this concept only, how Na2SO4 dissociate, KNO4 dissociate, similar, beta, if in question agar K2SO4 given hota, then how will you write this? I, what I comes out to be? It is given that it undergo 100% ionization. Okay, if it will not give 100% ionization, then it provided whether it will go 50% ionized or 25%. Then we use the concept of alpha. Otherwise, there is no need to use alpha, because we know that now what is I? I is nothing but 1 plus n minus 1 into alpha. So if the alpha is 1, then automatically I is equal to n, right? So I is nothing but n. So just calculate the number of ions. Okay. So in case of K2SO4, what is the number of ion, beta? 2 ions of K plus 1 ion of sulfate. So total number of ion is nothing but 3. So by this you can calculate. Similar, if I'm talking about K2FeCN6, right? So if I'm talking about K2FeCN6, then how will you calculate this? We can calculate this by 2K plus, and this will give Fe. This will give Cn6, right? So this is how we can calculate. So in this also, number of ions is nothing but 2 plus 1. That is, number of ions is equal to 3, or we say Vento factor is also equal to 3. So such kind of question, in such kind of question, we have to calculate the value of I, and which is equal to n, so that we can easily solve which one showing a more TB or more boiling point of the solution. All right. Okay. So I hope this is clear to you all. सबको समझ आ गया ये? सबसे पहले आई निकालना है हम लोगों को. आई कैसे निकालेंगे? देख लेंगे कौन सा कंपाउंड दे रखा है, उसको तोड़ के देख लेंगे. आई और एन हमेशा इक्वल होंगे अगर वो 100% आयोनाइज्ड है. तो इन सभी चार ऑप्शंस में हमें साफ साफ पता लग गया कि जो Na2SO4 है वो मैक्सिमम शो करेगा. ठीक है, बिकॉज उसमें नंबर ऑफ आयंस क्या है? ज्यादा है. आई होप दिस इज क्लियर टू यू. Okay. Now, the next question is, and this one is very, very important question. So please try to understand. And this is very simple question as well. So in this question, the unit of ebullioscopic constant. So you have to calculate the unit of ebullioscopic constant, right? So just try to find out the unit of ebullioscopic constant, beta. What is ebullioscopic constant, KB or KF? Tell me first. What is ebullioscopic constant, KB or KF? Yes, KB. So we know that delta TB is nothing but equal to KB into molality. So what is KB, beta? KB is nothing but delta TB divided by molality, right? And what is the unit of delta TB? We all know delta TB is nothing but Kelvin. Okay, so delta TB is nothing but Kelvin, and molality, will express molality into mole per kg, right? That is mole per kg. So this is the formula for molality. We can also write now this is as K and molality. Molality inverse. Right? So both are correct. So which option is correct, beta? That is K kilogram and mole inverse. So K kilogram and mole inverse and K molality. The option number A is absolutely correct. आई होप सबको समझ आ गया होगा ये ऑप्शन ए कैसे करेक्ट हुआ. बहुत सिंपल क्वेश्चन था, ज्यादा कुछ था नहीं इसमें. Next, this one is very, very important question, beta. So try to solve this question. In this question, the molar freezing point constant for water is given. It means what they provided a solution that is, first of all, write the given quantities. We know that here Kf is nothing but 1.86. So this is known as molar freezing point constant, and 1.86 for water, right? So this is a constant. Okay, so this is Kf. If 342 gram of cane sugar, yani this is the mass of solute. So mass of solute is also given. Mass of solute is nothing but 342 gram. Okay, cane sugar. So molar mass of cane sugar. Now you can easily calculate molar mass of cane sugar beta because the formula is provided now. So we can calculate molar mass like 12 into 12 plus 22 into 1 plus 11 into 16. So just by solving, we get 342 gram per mole. So this is the molar mass of the cane sugar. Now is dissolving. So this is mass of the solvent is also given. So mass of solvent. Mass of solvent is also given. How much beta? 1000 gram. This is 1000 gram. Right. Now you have to find the solution will fridge at. So you have to find the freezing point of solution, that is TF. Right? TF naught is what? Freezing point of the pure solvent. TF is what? Freezing point of the solution. And delta TF is what? Depression in freezing point. So for doing any question, if you want to do such question in an easy way, na, first of all, just write what is given in the question, right? Once you know what is given in the question, what is asked in the question, what is the formula of this question, then you can easily solve such questions, right? So doing any numerical related to physical chemistry, you must adopt this technique because it is very beneficial. First of all, just write what the data is given. Okay, and now remember the formula behind this. So if you just write the data in a good way and remember the formula, just put the value, you'll get the answer. So there's nothing much to do in this question, right? So this is very simple one. So what the question asked with the freezing point of the solution? We all know we have a formula for the freezing point of solution, but before this we have to calculate depression and freezing point. So for any times whether they ask a freezing point of the solution or boiling point of the solution, first of all, you have to calculate either elevation in boiling point for the case of boiling point of the solution or depression in freezing point for the case of that is freezing point of the solution, right? So first of all, you have to calculate the colligative properties. So now let's calculate delta TF. So we all know that what is delta TF beta. So delta TF is nothing but is equal to KF into molality and into I. So in this cane sugar is given. So for such compound, covalent compound, I is always equal to 1 because they will not undergo any dissociation or association, right? So what is delta TF? So delta TF is nothing but KF, which is equal to 1.86. Molality is nothing but mass of the solute, right? Mass of the solute. Let me write once. Mass of solute divided by molar mass multiply by 1000, okay, and divided by mass of the solvent. Okay, so delta TF is equal to 1.86 into mass of the solute upon molecular mass into 1000 upon mass of the solvent, right? So this is all about the delta TF, right? Now just put the value beta. Delta TF is nothing but 1.86 and mass of the solute is nothing but what is given with the 342 gram. So 342 gram. Molar mass is also provided, which is also equal to 342 gram. And this is 1000. And what is the mass of solvent beta? This is also equal to 1000. So this quantity get cancelled. So this delta TF comes out to be 1.86 only. So this is the delta TF, which is equal to 1.86. Is it okay? Right? Now you have to calculate. This is 1.86 degrees Celsius, right? So this is comes into degree Celsius. Now you have to calculate beta the freezing point of the solution. So we know that delta TF is equal to the first step. In every question, step number one is very much similar. You just have to calculate delta TF or delta TB. Once you calculate this delta TF and delta TB now, then in the next step, you have to calculate the boiling point solution or the freezing point of the solution. So we know that delta TF is nothing but TF naught minus TF. What is the freezing point of the solution, beta? 0 degrees Celsius minus 1.86. So it comes out to be minus 1.86 degrees Celsius. So this is the, no, this one is 1.86, right? Let me correct this, and this is TF, freezing point of the solution. So the freezing point of the solution on solving comes out to be minus 1.86 degrees Celsius. And which one? Option number A. Option number A is absolutely correct for this question. I hope this is clear to you. सभी को समझ आया क्या ये क्वेश्चन? सबको समझ आया? बहुत सिंपल क्वेश्चन था, बहुत इजी क्वेश्चन था और इसी तरीके के क्वेश्चन पूछे जाते हैं। तो तुम्हें पता होना चाहिए कि कैसे फॉर्मूलेस यूज करने हैं, कैसे वैल्यूज जो गिवन है उनको एक साथ रखना है, वैल्यूज को पुट करना है और फिर सॉल्व करना है, राइट? सो तुम बहुत इजी तरीके से ऐसे क्वेश्चंस को फाइंड आउट कर सकते हो। सो आई होप दिस इज क्लियर टू यू, राइट? नाउ लेट्स मूव टू द नेक्स्ट क्वेश्चन. इन दिस क्वेश्चन व्हाट दे आस्क बेटा, the amount of ice that will separate out on cooling a solute containing 50 gram of ethylene glycol in 200 gram of water to 9.3 degrees Celsius will be. So you have to calculate the amount of ice that will be separate out on cooling. So you have to calculate the mass of the solute in this question. So what data is given? Let me write first the data. So the solution pass consists of, first of all, given. So what is given in this question, beta? Batao jaldi jaldi. The amount of ice that will be solute containing 50 gram of ethylene glycol. Okay. So mass of the solute is already given and it is equal to 15 gram. So the amount of ice that will be separate out on cooling of a solute containing 50 gram of ethylene glycol in 200 gram of water. So mass of solute is, mass of solute is nothing but equal to 50 gram. Now, ethylene glycol. So what is ethylene glycol? Because you have to calculate the molecular mass for this. So molecular mass of ethylene glycol, beta. So what the molecular mass of ethylene glycol comes out to be? Tell me fast. Molecular mass of ethylene glycol is nothing but equal to, yes. Good. Okay. So the molecular mass of ethylene glycol, first of all, we need to know the formula of ethylene glycol. So this is nothing but CHOH, CH2, CH2OH, ethylene diglycol, right? Ethylene diglycol is known as ethylene glycol, or we known as ethane 1,2 diol. So what is the molecular mass of this beta? We have a 2 oxygen, 1 and 2. So 16 into 2, right? Now how many hydrogen we have? 2, 2, 4, 1, 5, 1, 6. So this is 6 into 1. How many carbon we have? C into C, that is 2. That is 12 into 2. So by solving, we'll get the molecular mass is equal to 62, right? So 62 is the molecular mass in 200 gram of water to minus 9.3 degrees Celsius. So delta TF is given, delta T, and delta T, that is depression and freezing point, is given, and it is equal to minus 9.3 degrees Celsius. KF is also given, 1.86, right? This is in Kelvin kilogram per mole. Remember this thing here, 9.3, and this is given in this question, right? Now, what the question asks? The amount of ice that will be separate out on cooling a solute. If you want to cool down a solute, right? So amount of ice that will separate out on cooling a solute containing 50 gram of ethylene glycol in 200 gram of water. So here the total water is given 200 gram. Now you have to calculate ice separated. What amount of ice gets separated, right? So first of all, you need to calculate now. What is beta? Let me show you. This is delta TF, which is equal to KF, sorry, KF into molality, that is mass of solute divided by molar mass into 1000 and divided by mass of solvent, right? So in this, you need to calculate mass of solvent first. Delta TF is given already. How much beta? 9.3. 9.3 degrees Celsius. How will it come beta? We know that delta T is nothing but is equal to TF not minus TF. So what is this TF? So this TF comes out to be, right? TF comes out to be delta TF naught. TF naught is nothing but 0 degree, right? So this is 0 degree Celsius minus 0 degree minus, what is delta TF? Delta TF is already given, minus 9, that is 9.3. So minus minus, this will become plus. So it will equal to 9.3 degrees Celsius. So this is the freezing point of the solution. Just put this. So the freezing point of the solution is nothing but 9.3 degree Celsius. Okay. What is KF here? KF is already given. It is equal to 1.86. Now, what is the mass of solute in this question? So mass of the solute is already given. That is 50 gram. What is molar mass? That is 62. This is 1000. And this you have to calculate. So what is this W? This W comes out to be nothing but 1.86 into 50. Right? 1.86 into 50 into 1000 divided by what beta? 9.3 into 62. Right? 9.3 into 62. So what is W comes out to be beta? Solve this. On solving, you get W is nothing but is equal to 161.3 gram. So this is the mass of the solvent, right? So this is the mass of the solvent. Now we already know that the total water present here is how much? The total water present here is 200 gram, right? So let's see, the total water present here is total water present. So total water present here is 200 gram, is equal to nothing but 200 gram. Now, hence, what amount of ice separated? So hence, ice separated. So ice separated is equal to nothing but 200 minus 161.3 gram, right? And it comes out to be 38.7 gram. So which one is the correct option for this question, beta? 38.7 gram. That is D. Because in this question, they are asking about the amount of ice that will be separate out on cooling, right? A solute containing 50 grams. So the total mass of the water is given 200 gram, and we also calculate the mass of the solvent. It comes out to be 161 point something. So just subtract these two values. So we get to 38.7 gram as the correct answer for this question. So this is also very good and very interesting question, right? Now, this question is also very, very important, and you all need to solve this question, right? So that you can understand the concept in a very good way as well. So, in this question, what the question asks, beta? A 5% solution of cane sugar. So, what is given data? Let me write the first. What is given data? So, 5% solution of sugar cane having molecular weight 342 is isotonic. What do you mean by this term isotonic? Isotonic means what, beta? Having same osmotic pressure. Having same osmotic pressure. Right. So having same osmotic pressure is known as isotonic. So a 5% solution of sugar cane is isotonic for 1% solution of X. It means the 5% solution of cane sugar, it means the osmotic pressure of cane sugar, right, is equal to osmotic pressure of this compound X. Under the similar condition, you have to calculate the molecular weight of X. So how will you calculate beta? We already know that pi is already equal to CR into T. This is also equal to CR into T. This is for X and this is for the C, cane sugar. Now here R and T are same, so R and T cancel out each other. What is concentration? Concentration is nothing but is equal to number of mole per unit volume. So this is for C. This is also equal to number of mole per unit volume. This is for X. Volume is same. Now what is number of mole? That is mass of the solute upon molar mass. Molar mass of what? C. Here also mass of the solute upon molar mass. So you have to calculate this molar mass, right? Capital M. So how it comes out to be this molar mass of X. Yeah, you need to calculate now. This comes out to be mx, that is mass of the solute divided by mass of the cane sugar multiply by molar mass of the cane sugar. So it's equal to what is the mass of the unknown solute beta? A 1%. It means 1 gram out of 100, right? And what is mass of this? The 5%, that is 5 gram. And what is the molar mass of cane sugar? That is 342. Okay, so it comes out to be 342 divided by 5. So the correct answer is 342 divided by 5. So you'll get like 68.4. So 68.4 is the absolutely correct answer for this question. I hope this is very easy to understand. Here, one important note here is isotonic. If the student don't know the meaning of isotonic, then they are unable to do this question. So it is important because we already discussed this thing in a very detailed way. That is what is isotonic solution, how what is hypertonic, what is hypotonic. So these are things are very important to know. What is mass percentage? Because only through mass percentage we get to know 5% means 5 gram, right? 5 gram out of 100 gram of the solvent. 1% means 1 gram out of 100 gram of the solvent. So these small things are very important. If these small things are not get cleared, then you have faced difficulties in solving questions, right? So please try to understand this thing as well in a good way so that you can utilize these things in a solving doubt solving problem or in solving some numerical, because physical chemistry is all about doing practice. How many question you perform, the more question will you perform, the more question you will practice, the more accurate you will be, right? So try to solve this question. Now I'm giving one homework question for you all. Try to solve this question. So this is the homework question for you all. Try to solve this question. Okay. Try to solve this question in a good way. Try to understand what they ask, and just by using the simple tricks that we are already discussed, that is the elevation and depression, right? So try to solve this question. This is the question number 1. I'm giving homework number 1, question number 1, and this is question number 2. So try to solve these two questions, right? In next class we are going to discuss this question as well, and also look some other things that we are need to complete in this chapter, right? So thank you for the today's session. Now let's meet on the next class, and in the next class we are going to do some things, right? So take care and keep learning and keep practicing all these things. Okay.